Today we're talking about scientific notation. What is scientific notation? Well, scientific notation is a means of expressing very large or very small numbers into a more convenient / compact form. This is achieved either by factoring or multiplying by factors of 10. Let's take a look at a few examples to get a better understanding exactly how this is done. Let's take a look at example 1. All right. Now here we have a fairly large number that we need to convert into scientific notation. Now traditionally when we take a look at a number like this is actually even fairly hard to read. So if we put in a few commas in here, we can see that this number is 345 million. Now writing 345 million is problematic for the following reasons, is that you have to deal with remembering how many zeros there are. But scientific notation allows us to simplify this process. And let's take a look how that is done. So let's take a look. We can take 345 million and we can express it into something that is a little bit more reasonable and a little easier to look at. So let's take a look at this value here. This is the same as taking 3.45 and multiplying it by 100 million. All right, but that is also still a very bit on the awkward side. What we can simplify even further still is take a look at how many zeros we have in this number. If we count them, we've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. That means we can actually simplify this 100 million down to 10 to the power of 8. Therefore, we can actually express our number instead of as 3.45 times 100 million, we can actually express it as 3.45 times 10 to the 8. And this is what we refer to as scientific notation. Now, this looks more complicated than it actually is. There's actually an easier way to do this. We don't actually have to do this step here. We can skip that step. And all we have to do is take a look and move this decimal place by following number of jumps. So we can jump like this: 1, 2, 3, 4, 5, 6, 7, 8. We did 8 jumps with the decimal, and therefore we can simplify it and write it as 3.45 times 10 to the 8 like this, without having to go through these steps here. Now, what happens when we are dealing with a small number? So let's take a look at this value over here. We have 0.00056. Now, this is a difficult number to write, let alone say, but we're going to do something very similar. But instead of multiplying, we're going to be dividing. So this value, 0.00567, is the same as 5.67 divided by 10,000. Now, again, we can clean this up. Instead of writing it as divide by 10,000, we can write it as multiply by the reciprocal of 10,000. However, 10,000 can also be simplified to multiplying by 1 over 10 to the 4. But that notation right here, this is a bit awkward. All right, it's this issue right here. It's difficult to write and it's not the standard form. So what we need to do is we need to actually express this into a more compact version in scientific notation. But before we do that, we have to explain how we can actually convert that into a proper notation. Let's take a look at this. 1 divided by 10 to the 4 is actually the same as 10 to the negative 4. Now the question is, why is that? Why are they the same? Well, in order to answer that question, what we need to do is we need to take a look at the rules for powers and exponents. So let's take a look at a few examples. What we're going to do is we're going to step back and we're going to do a little bit of review of some concepts that we may have learned back in grade 10. So let's start off with this example. We've got 100,000 divided by 1,000. Now, that is the equivalent of writing it here as a fraction form. Now, if we take 100,000 divided by 100, the final answer is 1,000. And we can do that by crossing out our zeros here. We're left with 1,000. Now, that's a fairly straightforward calculation. However, there's an easier way to do this. Let's take a look at that fraction again. And this time what we're going to take is this fraction, and we're going to convert our fraction into a power base 10. Well, let's start off with the numerator. If we look at the numerator, we have 5 zeros in this value, which is the equivalent of 10 to the 5. In the denominator, we have 100, which is equivalent to 10 to the 2. Now, if you recall the power rules back in grade 10, when you have the same bases, for example, 10 to the 5 divided by 10 to the 2, it's simply a question of subtracting the powers. So 10 to the 5 divided by 10 to the 2 is the same as 10 to the 5 minus 2, which is equal to 10 to the 3, or 1,000. Now, that is if we're dealing with positive powers, but the issue was how to deal with the negative power. Well, if we take this example and flip it, we can see how we get a negative exponent here. So let's do 100 divided by 100,000 this time. If we do 100 divided by 100,000, we again get 1 over 1,000, which is this response right here. Or, simplifying it, we can express 100 as 10 to the 2 and 100,000 as 10 to the 5. Following that same rule of subtracting our exponents, we get 2 minus 5. That gives us 10 to the negative 3. And that's how our negative exponents come into play here. There's our negative exponent right there. Now, 10 to the negative 3 is the same as 1 over 1,000. But 1 over 1,000 is equal to 1 times 10 to the 3. So what this means is that 10 to the negative 3 is the same as 1 over 10 to the 3. So the general rule is as follows. 1 over 10 to the exponent n is equal to 10 to the negative n being any number. So that's a little review of some of our concepts in exponents and powers, but let's get back to our original. So getting back to our original problem, what we were trying to do is we were trying to convert 0.000567 to scientific notation, but we got this kind of awkward notation, specifically this. Well, we can apply our new rule, which we can still see here at the top of the screen, is that we can convert this into a more convenient form. So this 1 over 10 to the 4 is the same as 10 to the negative 4. So we can rewrite this expression here like this. One more shortcut that we can use. Let's take a look at this value again, right here. So if we take a look at this number, we can do a similar trick that we did in the first time by moving the decimal place over. Now, if we take a look at this decimal place, we're going to shift it. But in this case, we're going to shift it 1, 2, 3, 4 times to this point. Now, since we shifted it to the right, that means the power is negative. So since we shifted the decimal place 1, 2, 3, 4 times, that will become 5.67 times 10 to the negative 4. So that's the basic rules of doing scientific notation. Now, one of the things we have to make sure is that we have to express our values in a specific standard form. So scientific notation always has the decimal place located in this position here, which means that there is only going to ever be one single digit in the ones column. A number like this, for example, 12.4 times 10 to the 6, this is non-standard scientific notation, and that's not how it's generally written. Now, occasionally you will see it in that form, and we'll demonstrate how we can deal with those more complex issues. Scientific notation is just a question of shifting the decimal points to the left or shifting them to the right. And that's where we get our various values. And that's it. Occasionally we run into a problem where we're dealing with non-standard scientific notation. Now, non-standard scientific notation is done for a variety of reasons. However, what's important to know is how to convert it to regular scientific notation. In order to do this, we first have to understand how scientific notation affects the decimal places. So what we're going to do is we're going to consider the following examples. We have 45,000 first. Let's take a look at the value 45,000. And let's take a look at what each individual column represents in terms of a number. So if we focus here, traditionally when we take a look at this, this would be our ones column, right? So that's our ones. Now this column here, that's our tens. This is our hundreds, thousands, and of course finally 10,000. Now when we look at this, this isn't the most convenient way to write it, so what we're going to do is we're going to use powers to represent this. So let's rewrite this in a more compact form. Well, our ones column, that is the same as 10 to the exponent 0. So 10 to the exponent 0 gives us the value of 1. This would be 10 to the exponent 1 for the tens. This would be 10 to the exponent 2 for the 100s. This would be 10 to the exponent 3 for 1,000. And this would be 10 to the exponent 4 for 10,000. Now notice how the powers, specifically the exponents of the powers I should say, increase to the positive direction as we go to the left. So 10 to the 0 is equal to 1, 10 to the 1 is equal to 10, 10 to the 2 is equal to 100, 10 to the 3, 1,000, 10 to the 4, 10,000. Now if you recall, from scientific notation, we need to take the decimal place and we need to move it over here. Well, if we just take a look at where this place is, we can see what our value of 4 actually is. And our 4 is in the column of the 10 to the 4 power. So when we look over here, if you look at the scientific notation, this is 4.5 times 10 to the 4. Now, what's curious about this, if we did not have this here, this right here would normally be our ones column. However, in this case, this multiplier of 10 to the 4 makes this value here not the ones column, but the 10 to the 4 column, as we can see over here. So this means now this is 10 to the 4, which means this over here is 10 to the 3. And as we can see over here, the 5 is located into the 10 to the 3 column. So let's review that again. So this is your ones column, tens, hundreds, thousands, 10,000s. So let's look at this one specifically here. That is 10 to the 4. This here is 10 to the 3. That corresponds to what this number is here. This number here, this 4 is still 10 to the 4. So we write it as 10 to the 4 like this, and this 5 here is 10 to the 3. As you can see, these line up with these. Let's go in the other direction. Let's take a look at this decimal number. Now, with the decimal numbers, the numbers now start to decrease. This is still our ones column here. So this would be our 10 to the 0. But this is our tenths column, or 10 to the negative 1. 10 to the negative 1 is 1/10. Continuing that argument, this here would be the hundredths column, which is 10 to the negative 2. Thousandths, 10 to the negative 3. 10,000ths, oops, I forgot my negative. 10 to the negative 4. 100,000ths, 10 to the negative 5. And millionths, 10 to the negative 6. All right? Well, we are interested in these two right here. So when we move it into scientific notation mode, that 6 there is the same as this 6 over here. So since this is 6 in the 10 to the negative 5 column, this is 6 in the 10 to the negative 5 column. That means this 7 here is the 10 to the negative 6 column. All right, so let's recap that again. So if we take a look here, this is 10 to the 0, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, 10 to the negative 5, and 10 to the negative 6. So when we look at it from a scientific notation perspective, that's 6.7. That 10 to the negative 5 refers to that 6, and the 7 here would have to be 10 to the negative 6. Let's apply that to fixing our non-standard scientific notation. So how can we apply that in this case? Well, what we're going to do is we're going to reverse that idea that we did originally and apply it here. Now, let's take a look at this value right here. Normally, if this was not here, normally this would be your ones column, or 10 to the 0, normally. This would be 10 to the 1, or your tens column, and this would be your hundreds column. However, because of this multiplier here, that all changes. This affects all of these. That means this now is 10 to the 6. This here is now 10 to the 7, ascending, going to the left. And this 2 is now 10 to the 8. So if we move our decimal place over here like we did here, that 2 is 10 to the 8, that 4 is 10 to the 7, and that 5 is 10 to the 6. All right? So all we have to do is we have to focus on what this value, where it is located in terms of its power. So again, let's take a look and review this one more time. This 5, that is your 10 to the 6. That makes that 10 to the 7, and that makes that 10 to the 8. So that 2 is the same 2 here, and it is times 10 to the 8. And that's all we have to do to fix it. Let's take a look at the next example. So again, when we take a look at this value here, this 10 to the 7 affects our ones column. So let's take a look at how this works out. This 10 to the 7 affects this column here. So this column now, instead of being the ones column, this is your 10 to the 7 column. This column here is now 10 to the 6. We are decreasing in power. 10 to the 5, and that is 10 to the 4. As you can see over here. And this here is your 10 to the 3. So focusing on these two, that 5 is in the 10 to the 4, and that's what happens to that power up there. So 0.0056 times 10 to the 7 becomes 5.6 times 10 to the 4. One more time, just to make sure that we're clear. So we start off here, 10 to the 7. So we know that this is 10 to the 7. That makes this 10 to the 6, 5, 4. So that 5 becomes 10 to the 4, and that's how we fix our power. One more example. Our ones column is no longer a ones column, it's now the 10 to the negative 3 column. So if this is now 10 to the negative 3, this has to be 10 to the negative 4, 10 to the negative 5, and this is now 10 to the negative 6. And that is what we're focusing on right here. So when we take a look here, this is 3 times 10 to the negative 6. So when we move the decimal place, this becomes 3.4 times 10 to the negative 6. And that is how we get that final answer. That is it.